Hello viewers, welcome to the session. Let us now discuss a key feature in Java, exception handling. When a program is developed and executed for the first time, it may contain mistakes. These mistakes can cause a termination in the program or may even result in a system crash. The errors in a program may be either classified as compile time errors or runtime errors. Let us now see the difference between compile time errors and runtime errors. The errors which are caught during the compilation stage can be corrected and easily re-edited. Some common reasons for compile time errors include syntax errors, misspelled variable names, class names, interface names, package names, or object names. The improper termination of statements by missing semicolon could also be a frequent mistake. The improper termination of braces. Normally, curly braces are used to indicate code sections and square braces are used to indicate arrays. The next kind of errors are the runtime errors. These occur during the execution of the program. So some common examples are attempting to divide a value by 0, the incorrect usage of an array index, the incorrect specification of number format, or the illegal usage of typecasting. Moving to an exception, it is an abnormal condition which is caused by a runtime error in the program. Java provides a well-defined exception handling mechanism to handle various types of exceptions that occur during the execution of the program. Let us now discuss about default exception handling. When an error occurs during the execution of the program, the Java virtual machine checks whether any user-defined exception handling code is defined in that program or not. If no such code is present, then the JVM will automatically make use of the default exception handling mechanism and report the exception. Here is a program to illustrate the default error handling mechanism. A class named divide by 0 is defined. Inside the class is the main method, inside which there is a function called to the method A. Below the main method, the method A is defined, and inside the method A, there is a function called to the method B. So below which is the method B defined, and inside the method B, one can find a function called to the method C. So below the method B, the method C is defined, and inside which there is a function called to the method D. There is a definition of method D below the set of statements, which includes the declaration of two integer variables I and j, which are assigned values 1 and 0. We are attempting to print the value of I divided by j, which is 1 divided by 0. So we are attempting to print a value divided by 0. Let us now see the output of the particular code. So the output of the code throws an exception in the main thread. The exception that is thrown is the arithmetic exception, where we attempt to divide the value by 0. The set of statements that are involved are mentioned here, and the primary cause of error is the statement where we attempt to divide the value by 0. The name of the exception that has occurred is arithmetic exception, which is displayed in the first line. The line number of the statement that has caused the exception is displayed in the second line as 24. The drawbacks of default exception handling. There are two main drawbacks. The first one is it always reports the exception in a predefined format. And the second drawback is after reporting the exception, the program is terminated. Let us now discuss about user-defined exception handling mechanism. The user-defined exception handling mechanism is overcoming the above mentioned drawbacks. When an error condition is reported, it can be presented in a specified format, and the program execution will be automatically resumed after reporting the error. So here is the syntax of the user-defined error and exception handling mechanism. One can find the try block and 3 catch blocks followed by the finally block. All the set of statements in the program which are likely to have errors can be mentioned inside the try block, and each catch block can handle different types of exceptions. We have the finally block to execute a set of statements which should not be ignored at any cost. In the above structure, the try keyword is followed by a block of statements enclosed by braces. This block of statements will be monitored for exceptions by the JVM. If an exception occurs during the execution of a statement in this block, an object of that exception will be immediately generated. In such a case, the remaining statements will be skipped and the control will move to the first catch block that is placed next to the try block. In the try-catch structure, the try block is followed by a set of catch blocks. Each catch block tackles different type of an exception. If the type of the exception object matches the type of the exception parameter, all the statements in the block will be executed. If a match is not found, the remaining catch blocks will be examined for a possible match. If there is no matching catch blocks, then the Java virtual machine will automatically invoke the default exception handling mechanism. All the statements in the finally block are executed whether or not an exception occurs. The finally block is, however, optional. Each try block should be followed by at least one catch block or finally block. Otherwise, the Java compiler will report an error. Exception and error classes. The throwable class is the root of all error classes. Two immediate subclasses of this class are exception class and error class. The subclasses of the exception class, for example, the arithmetic exception and the number format exception. They describe the exceptions that should be caught by the user programs. The subclasses of the error class describe the conditions like the stack overflow or memory exhaustion or illegal access that should be caught by the user programs. The two important constructors of the throwable class include the method throwable and the method throwable with a string method. The two important methods of the throwable class include the getMessage method and the print stack trace method. The two important constructors of the exception class include the exception method and the exception along with the string message method. So here is a picture depicting all the classes of the throwable method. We can find the throwable class. The subclasses are the error class and the exception class. The error class has the explanation for all the unchecked errors, and the exception class handles all runtime exceptions, unchecked exceptions as well as checked exceptions. Moving to the next topic on error classes. Error classes are based and defined based on their conditions. For example, the class not found exception occurs in a state where the class is not found or the class name is wrongly mentioned in the code. The instantiation of exception occurs when an attempt was made to instantiate an interface or an abstract class. The runtime exception occurs because of any possible runtime errors. The array index out of bounds exception occurs because of trying to access any non-existing array position using a wrong index value. Arithmetic exceptions occur because of any wrong or invalid operations like division by zero or any probable methods. The class cast operation happens because of invalid casting. When we try to convert one class which is in a different data type into another class with a different signature, then the class cast exception occurs. We have the IO exception happening because of input-output errors. We also have the EOF exception happening because of the end of file occurrence. When we try to access a file location beyond the last value or the last used location in the file, then we have the EOF exception. We also have the file not found exception if at all the file name is wrong or the location of the file is wrongly mentioned in the code. We have the null pointer exception that occurs because of a reference to a non-existing object. And we also have the number format exception occurring when we attempt to make a wrong type conversion between the numbers or values. For example, when we attempt to convert a value from string data type to numerical data type, then such kind of errors or exceptions like number format exception will be thrown. Moving to checked and unchecked exceptions. Checked exceptions occur due to external circumstances that the programmer cannot prevent. However, unchecked exceptions occur due to our fault. Here is a program to illustrate user-defined error handling mechanism. So here is a class called as divider demo, the main method, and inside the main method is the try block. The try block within which we have two variables A and B which are receiving command line arguments being converted into type integer, and we are printing the value of A divided by B. There is a catch block to handle any arithmetic exception which prints the value error in denominator. There is also another catch block to handle the array index out of bounds exception in case there is a wrong value in the array indexes like here. There is another catch block to handle the number format exception because we expect only two values to be converted to integer. Those values that or that could be converted to integer should be used. If at all we give a value in type string or character, then we have to display the message called as data type error. Finally, you can notice the finally block where we have a statement called as the finally block, which should be printed. The value should be printed at any cost. So here is the explanation of the above program. Two integers are supplied as command line arguments. The try block is followed by three catch blocks. The first catch block handles arithmetic exception, for example, division by 0. The second catch block handles array index out of bounds exception. This exception occurs when the user forgets to give the command line arguments. The third catch block handles number format exception. If the command line argument is not properly formatted, then this exception occurs. So here is the output in different scenarios. So in all the scenarios, you can find the finally block being executed. So let us move to the next topic where we reflect on catch block searching pattern. Consider a program in which the main method calls the method A and the method A calls another method B. Let us assume that the main method, the method A and method B contain a try block and associated catch blocks. Suppose an error occurs in the try block of the method B and none of the catch blocks specified in method B can handle this error condition. The JVM will reach and search for suitable catch blocks in the method A. If no suitable catch blocks in the method A are available, then the JVM will search for it in the main method. If even in the main method the JVM does not identify the catch block, then it will invoke the default exception handling mechanism. Here is a program to illustrate backward searching. So defined here is a class search. Within the main method, within the try block, we can find a function call to method A, and there is a catch block to handle the exception that occurs inside main. There is finally a method to display the message that the finally block is working. There is also the definition of method A, inside which is a try block where there is a function called to the method B, and inside the catch block there is a code to handle array index out of bounds exception, and we can notice the finally block where we just indicate the final block works. Below mentioned is the definition of method B. Within the try block we can notice an array with values mentioned, and we also have a catch block to indicate class cast exception, and we also have a finally block inside this method. The throw statement. Java virtual machine generated an exception object when an error condition occurs in a program. Similarly, a user can generate an exception object inside a catch block as shown below. So this is the syntax by which we can generate an exception. So even in the catch block where we handle the exception, we can also generate a new exception. So please take a look. Catch followed by the arithmetic exception and the object. So if at all the arithmetic exception occurs, we print a message arithmetic error has occurred, and you can find a line here, throw E. So this throw E is a line which generates an exception. E represents the exception object of the type arithmetic exception. The throw E statement generates the exception object E once again. We can also generate the exception object within a try block. So we have the try block inside which we have the set of coding statements, and we can also include the throw statement along with the type of accepted or expected exception. So here we can find throw new array index out of bounds exception. The statements that follow the throw statement in the same catch block or try block will not be executed. Moving to the throws clause, some methods generate certain type of exceptions. For example, this input stream reader and buffered reader method, they can generate the IO exception. Such a method has an appropriate catch block to handle exceptions. However, such a method can instruct the caller method to handle them instead of handling it by itself. Here is a program to illustrate throws clause. So here is a class called as throw demo2. Inside the main method is the try block, where we have a value reader method through which we read a string value, and we have the catch block to indicate any input output exception. If at all it occurs, we display the message IO error has occurred. We can notice the value reader method being declared here. The method initializes the reader method, the reader object, as well as the buffered reader object. And we can display the value here. And here is a method, here is the output. Enter a string. If we receive a string, it prints the string. If at all there is a problem with the input, then it will display the message input output error has occurred. The value reader method may generate an IO exception object. Instead of handling the exception by itself, this method instructs a caller method or the main method to handle the exception. The instruction is provided using throws clause in the declaration syntax. So take a look at the syntax. Static string value reader 1 throws IO exception. Moving to the next topic on custom exceptions. We may define our own subclasses of the exception class to handle some special types of error conditions. For example, we may define the correlation exception subclass of the exception class to check the validity of correlation coefficients before using them in computations. Such classes are called as custom exception classes. After defining custom exception class, an error object can be generated using the throw statement whenever an error condition occurs. Here is a program to illustrate user-defined exceptions. So, the exception that is defined here is my exception, which extends the exception class. So I have a constructor here called as my exception, and a constructor with a message. And here is another class called as test my exception, which defines the main method inside which there are two variables x and y. X takes the value 3 and y takes the value 1000. So inside the try block, we attempt to divide the value of x by y and store the answer as a double value in z. If statement is used to check if the resultant value is less than 0.01. If at all the value is less than 0.01, then we throw a new my exception. This is the custom exception. So this line is the place where the error is thrown. The custom error or the custom exception is happening. If at all it occurs, we display this message called number is too small. We have the catch block to handle the my exception, the custom exception, and we print the message caught my exception, and we also print the message in the exception. We have the finally statement, and we can take a look at the output of the program. Caught my exception, and the number is too small, and the finally block also gets executed. Here is the explanation. In the above program, the name of the custom exception class is myException. Within the main method, the value of z is computed as 0.05. Because the value is less than 0.01, an object of the myException is generated. This object is caught and reported within a catch block. Thank you for your patient listening. I hope this session on exception handling was understandable. Thank you once again. Welcome back to yet another important topic in Java, which is multithreading. Earlier days, the jobs or tasks or processes in a computer system were executed one after another, after which we entered into the concept of batch programming, where the set of tasks were executed as a collective number, and after which this concept of multi-threading emerged, and because of which today we are able to run concurrent applications. Several applications are run on the desktop, and we can find many applications or the supporting files being executed or being run as background processes. Let us now get started with the topic about threads. Java enables us to describe within a Java program two or more lightweight tasks that can be carried out at the same time. A thread is a program unit that is executed independently of the other parts of the program. Many threads can be defined and used within a program. Threads do not have address space, but they use memory and other resources of the program in which they run. The time needed to perform a context switch from one process to another is very less. The Java virtual machine schedules the threads defined in the program and executes each one of them for a short amount of time, which is called a time slice, and then switches to another program. The ability of a programming language to support multi-threading is called concurrency. However, we have two problems while using threads. The first problem is where one thread may need a value that is being computed by another thread. In such a case, those two threads are to be synchronized. When two or more threads try to access a shared object, then there could be another problem of waiting. Let us now discuss about the life cycle of a thread. Every thread moves through several states from its creation till its termination. The possible states of a thread are new state, ready state, running state, waiting state, and dead state. Immediately after creating a thread, it will be in the new state. After the start method of the thread class is executed, it will move to the ready state. When the Java virtual machine selects it for execution, it moves to the running state. When the thread completes its execution, it will move to the dead state. If a thread is instructed to wait, it moves to the waiting state. When the waiting state is over, the thread once again moves to ready state. Sometimes the JVM may move a thread from running state to ready state in order to offer another thread an opportunity to execute. So the life cycle of a thread is depicted here as a diagram. We can notice the first state of the thread is the new state where the thread is being created. Once it is created, it moves to the ready state and it proceeds to the running state. If at all it has completed its execution, it moves to the last state, the dead state. If it has to be synchronized for some reason, it can be sent to either the waiting state or it could be sent back to the ready state. When it is sent to either of the states, either it is going to the waiting state, it has to resume its operations and it has to move to the ready state and then proceed to the running state and then go on with the execution. Or else, if it moves to the ready state, again it has to proceed to running state and finally execute itself and complete all its activities and finally reach the dead state. So this is the life cycle of a thread. Several threads can run together. However, they can be synchronized based on the resource requirements. Moving to the topic on creating and running threads. A thread can be created and run using the thread class. The thread class is available in the java.language package. Each thread is an instance of this thread class or instance of a subclass of the thread class. A thread can also be created using a runnable interface. This interface contains the declaration of only one method, namely run. So here is a program to create a thread using the thread class. So we create a class called as thread, which becomes a thread because we invoke and extend the thread class. We have the run method, and inside the run method we have the try block, inside which we create a counter from 1 to 5. We have a method called as thread.sleep to send any thread to a waiting state, and we can find we have a value 1000 mentioned here. This 1000 is a waiting time for the thread. We also have a message here, welcome to Java, below which we have the catch statement, which resolves or handles any interrupted exception that occurs. We create another class called as thread demo1, and inside the main method we create an object t1 for the thread called as thread1, and we call the start method using the object t1. We say t1 dot start, and the thread is now created. So the thread begins its life from this method. It reaches the run method, and inside the run method it begins its execution. It prints this message, welcome to Java. It proceeds into the loop again for the second time. After waiting for 1000 seconds, it prints this message, welcome to Java, the second time, and again proceeds into the loop for the third time and prints the message again on the third time. This activity continues for 5 times, and finally when it exits the loop, the program is terminated. So this is the output of the program. One can witness 5 statements being printed because of the loop, and all these statements are not printed at a stretch. They are printed on a time duration of 1000 seconds. That time duration is because of the waiting state of the thread. Here is the explanation about the above program. Using this object T1 of the thread class, the start method is invoked. At this stage, the thread T1 will be in the ready state. The JVM takes it up for execution subsequently. Now, the thread T1 will move into the running state. At this stage, the run method will be executed. Now, the string welcome to Java will be displayed 5 times at regular intervals of 1000 milliseconds. The execution of sleep method may result in interrupted exception. When the sleep method is executed, the thread will move to the waiting state. When the run method completes, the thread will move to the dead state. When a thread is created using a runnable interface, an instance of the class that implements this interface is passed to the thread constructor as its argument, as shown in the following example. So this is another program to create a thread, but this time using runnable interface. So the class thread3 is now a thread because it implements the runnable method. We have inside it the run method, within which we have a try block and a catch block. The try block contains a set of statements to loop and execute a set of statements to put the thread to wait for 1000 seconds and also display the message welcome to Java. The catch block handles any possible exception that occurs. We have another class called thread-demo2, inside which we have the main method, and we create the object Rx for the thread3, and please notice we create another object T3 for the thread class, which is assigned to Rx. So T3 is assigned to Rx. And finally, when we say T3.start, the thread is created. So at this instance, when we say T3.start, the thread is created. It begins its life cycle. Then it moves to the running state. When it reaches the run method, it finds two methods, the sleep method and the method to display the message. The output of the program is the set of statements "Welcome to Java" being displayed at an interval of 1000 seconds, at the end of which the thread reaches the dead state. Explanation: the thread 3 implements the runnable interface. An instance of the thread 3 is passed into the thread constructor as its argument. Then the start method is invoked. When Java Virtual Machine takes up the thread 3 for execution, the run method in the thread 3 class is executed. When the execution of run method is over, then the thread moves on to the dead state. Let us now discuss about the methods in the thread class. The thread class contains the static and instance methods apart from its constructor. Some important constructors of the thread class are the thread method itself, the thread method along with the runnable interface, the thread method with a string s, the thread method with a runnable interface and a string message. Let us now move to the static methods in the thread class. So the first method is static thread current thread. The functionality of this method is to return the reference to the current thread. Even though we have n number of threads working in the program, it returns the reference to the latest or the currently active thread. The second method is the void sleep long m method. This method causes the current thread that is being executed to abruptly wait for m milliseconds. The third method is the static sleep long m long n method. So this method causes the current thread to wait for m milliseconds and n nanoseconds. Moving to the next set of methods in the thread class, we have the void start method, which is used to start any specific thread. We have the second method, the void run method, which executes the functionality of the thread. We have the third method, boolean is alive. This method returns a boolean value true if the thread has been started and it has not yet died. If the thread has been dead, then it returns a value false. There is a method called as void set name followed by the argument s. This method is used to set the name of the thread to the string value s. The next method is string get name. It is used to return the name of the specified thread. We have the next method called as void set priority, where we can set the priority of a thread to a given value. And we have the last method, int get priority, when we want to view the priority of a thread. So this is a summary of all the instance methods in the thread class. Moving to the next topic on setting the priority of a thread. When multiple threads are getting executed, we can prioritize them based on their importance with the help of the set priorities method. The priority parameter can take a value between 0 and 10. The three static constants that are used to set the priority of a thread are max priority, min priority, and norm priority. So max priority represents 10 points, min priority represents 1 point, and norm priority represents 5 points. The thread scheduler picks the thread with the highest priority. If there are many threads with the same priority, the thread scheduler chooses one of them for execution. If the high priority thread wakes up after sleeping for some time, while the lower thread is running, the scheduler will run the higher priority thread and suspend the current low priority thread. A thread will complete its operations within the time allotted to it. Here is an example of thread priority. You can find a thread E being defined. Within the run method, we have a statement to display the message calling from thread E and quitting from thread E for a count of 2. And we also have another class called as thread F, which is a thread, and inside the run method there is again a statement to print calling from thread F, quitting from thread F on a count of 2. We have the third class, thread EF demo, and inside the main method we create the object for the thread E, the first thread. So TE is the object, and we assign the priority to the thread E. We assign its value as min priority plus 1. We begin the thread, and after its beginning we create and we start the second thread. We create an object called as TF for the thread F. However, we set its priority as max priority and we start the thread. Even though the thread E is executing, just because it has a lower priority value, this thread F, even though it starts late, because it was assigned max priority, it suspends the action or working of thread E and overrides thread E. So here is the output of the program. So the output of the program, we can see the working of thread F, the second thread. Although it began the second, we can find thread F being executed initially because it was assigned a value of max priority. And once the thread was executed successfully and it has completed its operations, then thread E begins its operation. So once thread E has completed its activities, its job, then finally it reaches the dead state. I hope this session on thread, multi-threading and setting the priority of threads was useful. Thank you for your patient listening. Thank you once again.